Lesson P.7. P7. We are solving inequalities algebraically and graphically. The concept here is algebra review. Okay, and especially solving this algebraically, this is algebra review. And in fact, I've already taught it in chapter 1 of algebra 2. So it's actually more like algebra 1 review. The graphically thing, that's going to be new. And we'll use our calculators to help do that. Okay? So, in the meantime though, solving absolute value inequalities. So, if the absolute value of something is less than A, then it is an AND inequality. If the absolute value of something is greater than A, then it is an OR inequality. If you had me for algebra 2, I'm going to say if it's a greater than sign, we make it an OR statement. If it's a less than sign, we make it an AND statement. Okay, so if it is a less than, I'm going to write this up here. And if you look back in the Algebra 2 notes, it's spelled less than with a D on the end. That's how we know it is an AND statement. If it has a greater than sign, you guys got it, right? Greater than, we use an OR statement. So it is important to watch the words there. Does it sound familiar if I say, okay, the first inequality is pretty much always the given. You just drop off the absolute value. The second inequality, we have to change, right? Whatever's in the absolute value stays, but then we change, I think of it as two signs. We change, in this case, we change less than sign to greater than sign and a positive A to a negative A. Same thing on the OR statement. You keep the first statement, so U greater than A, or stays U. You change greater than to less than, A to the opposite of A. Okay, so let's practice with example 1. The absolute value of x minus 4 less than 8. Right there, I see absolute value, so I know in my brain I'm going to have to set up 2. Now, first question that I teach in Algebra 2, is the absolute value isolated? Is my absolute value by itself? It is. It's just absolute value of x minus 4 on the left, so we're good. So, I'm ready to set up 2. What's the first one I'm going to set up? X minus 4 is, what sign is this? Do we need to review which sign is which? X minus 4 is less than 8. Okay. You can't think alligator mouth because we don't know what's bigger. But x minus 4 less than 8. What word am I going to use here to connect these statements? And. Because it is a less than sign, I'm going to connect them with the word and. What's my second inequality? Keep whatever's in the absolute value, and then what? Stays x minus 4? Yep. Less than becomes greater than. Positive 8 becomes negative 8. Okay. You know how to solve, yes? If it's x minus 4, I'm going to add 4 and get x less than 12. And if it's x minus 4, I'm going to add 4 to negative 8 and get x greater than negative 4. Because this is an AND statement, do you remember how we can rewrite it?
Don't you do like one layer than x and another?
Yep. When it is specifically an AND statement, this is when it needs to happen. You can rewrite this as a compound inequality. Your variable in the middle. Easiest thing for me to teach is I always say put the bigger number at the right, smaller number at the left. So bigger number at the right is 12. Smaller number at the left is -4. Carry those signs down appropriately, right? It was x less than 12, so it's still x less than 12. It was x greater than -4, but what happened with my x and -4? They flipped, and so now it's going to be -4 less than x less than 12. If done correctly, if you put your large number on the right, smaller number on the left, it should always work out that they are both less than signs. If it doesn't work out like that, you might have made a mistake somewhere. Now, this is pre-cal, and we try and work on interval notation in this chapter, or in this book class. Remember doing interval notation in the first half of chapter P? Instead of me writing this as a compound inequality, what's interval notation look like? Or have we already forgotten? Good. Parenthesis, -4, comma 12, parenthesis. And I am going to graph it. Because if I graph this, obviously we know they are normally open circles. Instead of open circles, we use parentheses. If it's x less than 12, it's going left of 12. If it was x greater than -4, it's going right of -4. Because it's an and statement, remember we look for where the graph overlaps, right? And that's in between. So typical and statement, shading is in the middle. And does this make sense for interval notation? My shaded interval starts at -4 with a parenthesis. It continues up through 12 with a parenthesis. Okay? Does that ring some bells? Okay. Let's try example 2. 2, absolute value of 3x minus 2 minus 3 greater than or equal to 7. What am I going to ask first? Is it isolated? Is my absolute value expression isolated? No. So don't try and solve it right now. That's the beginner mistake, right? We're going to get it by itself before we set up our two inequalities. So, if it's 2 times its absolute value minus 3, how do I get absolute value by itself? How do I move a minus 3? We're going to add 3. So 2, absolute value of 3x minus 2, greater than or equal to 10. Is my absolute value by itself yet? No. If it's 2 times the absolute value, we're going to divide by 2. Absolute value of 3x minus 2 greater than or equal to 5. Okay. Is my absolute value by itself now? Now we're there, aren't we? What do I do once I have that absolute value by itself? We're going to set up 2. What's the first one? The given, 3x minus 2 greater than or equal to 5. I need a word in the middle. Every time I need a word. Or, because it's a greater than sign, I'm going to use or. What about my second inequality? Okay, 3x minus 2 less than or equal to -5. Do the solving. Let's see if I add 2. 3x greater than or equal to 7. Then I have x greater than or equal to 7/3. Or add 2 over here. 3x less than or equal to -5 plus 2 is -3. Divide by 3. X is less than or equal to -1. Up above, it was an and statement. I rewrote it as a compound inequality. This one is an or statement. What's that mean? I can't rewrite it. Okay? It's going to be as listed as an or statement. Okay? It cannot go together with just an X in the middle. Now, what about interval notation? And what about a graph? Can you do the interval notation without a graph, or do you have to have the graph? That's a personal choice, I guess. And if we put the graph on here, what do we have? So x less than or equal to 1. How do I graph x less than or equal to 1? That is a bracket going left. Greater than or equal to 7/3. Where is 7/3? 7/3 is, what is a mixed number? 2 1/3. So that means it's going to be a little bit past 2, right? And so at 7/3, greater than or equal to, so a bracket, shading to the right. Does that help you set up your interval notation if you're a little hesitant? Where does my shading begin? At the left end, my shading begins at, what do we call that left arrow? Name infinity. What do infinities always use? Parentheses. Comma. Where does that interval end at? The shading ends at -1 with a bracket. With interval notation, we don't write the word or. Did I show this earlier this year? We use a U for union. That is your official set notation there. Where does this second interval begin? And it begins the shading at 7/3 with a bracket, comma. Where does this shading end at? The right arrow, so positive infinity, and infinity always uses a parenthesis. Okay. The rest of this goes into where we will talk at least somewhat about graphing. And I'm not going to actually write anything down for this one, but when we look at this, we're going to we're going to graph it, and we're going to look and see, in this case, what is this question asking me? Where is this equation greater than or equal to 0? On a graph, where would an equation be greater than or equal to 0? What's that going to mean? Where are numbers bigger than 0? And notice this is the whole graph here. So we're not just talking about specific x, we're talking about the whole equation here. So think in terms of y. Where are y values greater than 0? What? Up. Above the x-axis. So when we graph this tomorrow, we're going to be looking to see where is this graph above the x-axis. Sorry, I lied. I wrote something down, didn't I? Okay. So that's where we'll start out tomorrow. And we'll do a little bit of actually work on the paper also, just kind of looking at how, we can do some factoring stuff. But we'll work at that. In terms of what you can do on homework, the ones that are actually solving. The graphing ones, I wouldn't mess with yet. I know some of you like to get ahead on homework, but you're welcome to look at the book and try. But I will definitely teach lots about that tomorrow. So, okay?